Oh, 잠깐만. Oh, 봐봐.
The longing has for ages been a secret that slept with the legendary pharaohs of Egypt. The human heart is easily taken in by things shiny and valuable. For over 4 millennia, the longing has been waiting patiently for this moment. Now, it is about to open the floodgates on the secret knowledge of the world. This place is a pilgrimage for those who wish to seek out our origins. That there were as many gods in ancient Egypt as there were people. And among them, there was a deity who helped people do math. This is Hapi, the god of the Nile. This is the world's longest river, 6,600 kilometers long. The fact is, there is often abundant rain in countries south of Egypt. The rainy season in Ethiopia and Uganda is the source of water for the Nile River. Ancient Egyptians who were unaware of this believed Hapi brought water to the Nile. The river's waters left sedimentary deposits from the upper river to the delta. The rich black soil that resulted was revealed whenever the water subsided. Every year, the fertile soil was replenished, but the land boundaries were completely obliterated. Returning use of the land to his people was an important responsibility of the pharaoh. Re-establishing plot boundaries was a math problem. Some of the borders were curved, not straight. And this required a way to find the area of circles. Calculating the area of a circle required pi, a value of about 3.14, but pi had not yet been discovered. How could they determine area? This was problem number 50 on Ahmed's list. Find the area of a circle that is 9 ket in diameter. But first, we must determine what a ket is. This is a finger, perhaps the smallest natural unit of measure to the ancients. The Egyptians measured length using the human body. The next largest unit was the width of 4 fingers. In the human body, 6 times the width of 4 fingers was equal to the length from the tip of the fingers to the middle of the arm. The length of the forearm was 1 cubit, and there are 100 cubits in 1 ket. A length of 9 ket would require a lot of people standing in line. 100 cubits makes 1 ket. The problem written on the papyrus referred to 9 ket. That would mean 900 forearms needed to determine 9 ket. 900 people with their forearms out are lined up side by side. So this is a circle with a diameter of 9 ket. How could the Egyptians determine its area? First, they divided the diameter by 9. Then, they eliminated one of the 9 sections. This left them with 8. The area of a square with a side that is 8 units long is 64 square units. This would be the area of the circle as the Egyptians calculated it. So how did they know that the area of such a square would equal that of a circle they're calculating? This is a square made up of 64 pebbles. Try reworking them into the shape of a circle. The number of pebbles in the diameter of such a circle is 9. This is how they concluded that the area of such a circle and square are about the same. Let's calculate the area of the circle using the value of pi. It turns out to be 63.59. The Egyptians calculated it at 64. That's a very negligible difference from modern mathematical methods. Ranking government official who imposed taxes on wheat production. His duties are depicted in paintings on the wall of the tomb. Agriculture was the primary source of income for the kingdom's treasury. In order to levy taxes fairly and accurately, scribes documented everything. Each year after the annual flooding, government officials went out to survey the land. For accurate taxation, precise land measurement was crucial. Farming began long before the harvest. To properly distribute land to the farmers, the officials had to study diagrams. In other words, they relied on geometry. They made knots in rope in order to measure length. From there, plots were determined. The measurement of area required another form of math: multiplication. Measurement of land area was so important that it was mentioned in 13 problems on the papyrus. A triangular or rectangular plot of land required multiplication. So how did Ahmes calculate them? For example, how was an area of land, say 4 meters by 5 meters, measured? 4 by 5. 4 times 5 is 20. The thing is, the ancient Egyptians didn't have our present-day form of multiplication. So how did they figure out the area? 4 by 5. Let's start by placing 4 white pebbles on the left. Then, place 1 black pebble. Then we double the pebbles on each side. Double of the right side is 2. We repeat this until there are 5 black pebbles. Now we've placed 5 pebbles on the right side. At this moment, the number of white pebbles on the left is 20. Now the measuring is done. The farmers can get on with their work. But for things that had little or no relationship, how were they grouped? Perhaps they could be separated into what's in the sky and what's on land. Things could also be separated into those that are alive and those that aren't. How about edible and inedible? Well, then how about this? One, 2, 3. Only humans do this. Three sheep equals 3 rocks. This is how humans discovered the numerical concept of objects. Humans began to keep track of the value of the sheep by putting pebbles in a container. These are some of the vessels used to hold the numbering pebbles. Since these devices represented property, we can think of them like a present-day bank book. This is the original papyrus scroll upon which Ahmes wrote. It was handed down from robbers to merchants. It finally arrived at the British Museum. This humble scroll has led us to the origins of everything in civilization. Here, we see problems we have solved so far. This is the one where 9 pieces of bread are divided among 10 workers. This is where they calculated the area of a circle with a diameter of 9 ket. We know there are even more amazing stories in this scroll waiting to be told.